everyone, welcome to this short tutorial demonstrating how we do scales when we're doing graphs. In today's video, we're focusing mainly on the 1 centimeter to 1 unit scale, as well as the 2 centimeter to 1 unit scale. Want to learn how to use your scales? Be sure to come prepared with graph paper, pencil, ruler, and an eraser. What do we use scales for? Usually we have to do graphs. We'll have to represent data, and each axis is probably going to be representing a lot more than just single unit data. For this reason, scales are applied. In some instances, we use large scales, and some we use small scales. We use larger scales when we have very small data that we want to enlarge the space so that we can get a more accurate plot of what we're doing. Whereas those smaller scales, we use those when we have very large data. We're trying to force it to fit into the space. So let's get started with our scales today. So this is what your graph sheet would look like, and when you look at a graph page, you'd notice that it's broken up into tiny little blocks, and then you'd also notice that you'd have larger divisions. So the grid that I'm using right now would not have the larger divisions that you would normally see on your graph paper. But what you need to know about the larger divisions is that those larger divisions represent 1 centimeter. So each of those larger squares, which normally would contain 5 tiny squares, that represents 1 centimeter. So if we were to try to draw the x and y axes on the graph paper, what you normally would try to do is divide your page into 4 equal quadrants as best as possible. So just for the purpose of illustration, what your Cartesian plane is going to look like on your graph paper, I'm drawing in the x and y axes. So I just divide the page. Like I said, I want to divide it equally in both directions, vertically and horizontally. Now what we're going to do is mark off where the 1 centimeter units will be on your graph page. So as I mentioned before, on your graph page you'll notice that it's divided into tiny blocks, and then you'll notice that it's divided into some larger blocks. Those larger blocks usually contain 5 of these tiny little blocks. So on my graph page, what I normally notice is that there's a division every 1 centimeter, which marks off each of those particular units. So when we do that now, this tells us where 1 centimeter is. And when they talk about scaling your graph, you're talking about whether or not you want to use 1 centimeter to represent 1 unit of what you want to represent on the axes, or if you want to use another type of scale where you could be using 2 centimeters to represent 1 unit of whatever quantity, or you might use smaller scales, right? It all depends on what you're trying to represent, what you're trying to fit onto these axes. So what does a 1 centimeter representing 1 unit scale look like? This one is going to have every 1 centimeter marked off as representing 1 unit in both the x and y directions. So I'm going to just set that up and I'll show you what it looks like. So this is what your graph page would typically look like, where you would have divisions in the x and y direction, and you'd notice that, like I said, each of these larger squares contain 5 of these little tiny squares. So one of the larger squares represents a total distance of 1 centimeter. So anytime you want to represent data on your Cartesian plane, you're always going to be thinking about what sort of scale you'd want to use to represent that diagram, that graph. When it comes to plotting points, we use different scales, especially if it is our Cartesian plane. Using a 1 centimeter to 1 unit scale won't necessarily facilitate all the values that we want to plot. So what we're going to do now is talk about our scaling. Okay, so now when we talk about setting up our scales on the respective axes, let's just say I wanted to use a 1 centimeter to represent 1 unit type of scale, then on the axis, let's say I'm looking at setting up my x-axis with that particular scale, I will mark off where my origin is. So that's why we want to ensure that we try to divide our graph page into 4 equal pieces as best as we can, and we're going to mark off where both our axes intersect as the origin. The origin is right here. Now at this point we're going to determine which direction we're going to be marking off first, and if we're working on the x-axis, we're going to be starting on the right. Every 1 centimeter we're going to represent 1 unit, so that means at every 1 centimeter I'm going to mark off 1 unit. So this is what that 1 centimeter to 1 unit scale will look like on the x-axis. Now we can mark it off in the opposite direction as well, because our axes don't only stay on the positive quadrant, we know that it also can have negative values. So let's mark off with the same exact scale, moving to the left. Alright, so this is what our 1 centimeter to 1 unit scale looks like, and we usually like to indicate the scales that we use. So we write that in somewhere on our graph page to just indicate that this is the scale we're using. So a scale can be specific to one axis, or it can be for both. In this particular illustration, just to demonstrate the different types of scales, especially the major ones, I'm going to use the 1:1 scale on the x-axis, and I'm going to use a 2:1 scale on my y-axis. Okay, so let's work on representing the y-axis using a 2 centimeters to represent 1 unit scale. I'm going to count 2 1 centimeter unit squares and then mark off 1 unit. So 2 1 centimeter unit squares would be at that point, and I will mark this off as 1. So this is what it means to have a 2 centimeter to 1 unit type of scale. Every 2 centimeters I'm going to represent 1 unit. And again, because the axes aren't restricted to only one direction, we're going to label the positive and the negative, and this is how we do our scales. So this is a 2 centimeters representing 1 unit scale on my y-axis, and just like I said before, I'm going to mark down what this scale is, so I'll know that I'm using a different scale on my y-axis as compared to my x-axis. And that's essentially how we do scaling